In this problem, we're asked to take a given table and identify where this function is increasing concave up, increasing concave down, and so forth. I've already marked up this document a bit with some information and calculations that we're going to use as we think about this. So on the left side, we have the input x values. I see that the x values are increasing in increments of 2 every single time. But we see that the y values do not have a steady increase or decrease. As the x values increase from -2 to 0, the y's increase by 20 units. So if you think about the graph, on average, as you go over 2, you would go up 20. That means that the average rate of change on that interval, the change in y over change in x, is 20 divided by 2, which is 10, positive 10. So if you think about the graph of f of x on that interval from x is at -2 to x is 0, on average you'd go over 1 up 10, over 1 up 10. Then as you travel from x equals 0 to x equals 2, this time the y values only increase 8 units. So from x equals 0 to x equals 2, the average rate of change is 4. So on average, you go over 1 up 4, over 1 up 4. Notice that it is less steep. It's still going up, but before the function was steep, over 1 up 10, over 1 up 10. Now it's less steep, over 1 up 4, over 1 up 4. That pattern continues as we go from x equals 2 to x equals 4. This time, the y value only increases 6 units. So the slope on that interval is an average rate of change of 3, over 1 up 3, over 1 up 3. So again, what happened with the function here is from -2 to 0, it's very steep. And then as you travel from 0 to 2, it's less steep. Then as you travel from 2 to 4, it's less steep, and so forth. If you put all this together, if you think about what the function must look like from x equals -2 all the way over to x equals 4, it must be increasing very steep, then increasing less steep, then increasing less steep. It is increasing concave down. Positive slopes, but the slopes themselves are decreasing. Positive slopes, so the function is increasing, but the slopes themselves are getting smaller and smaller, so the function is concave down. Let's try that again. So now, if you travel from x equals 4 to x equals 6, the slope was positive 1. As you travel from x equals 6 to x equals 8, now the y values actually decreased. The slope from x equals 6 to x equals 8 is change in y over change in x, -2 over +2, which is -1. Thinking about that, what that must look like. The function now must be going down because the slope is negative. On average, it goes over 1, down 1. As we then travel from x equals 8 to x equals 10, the slope now is -2. So if you think about what that must look like, slope of -2 would be more steep. The function is decreasing because the slope is negative, but now we're going over 1, down 2. And again, the pattern continues. On the next interval from x equals 10 to x equals 12, the slope now is -4, over 1, down 4. So it's even more steep. For this entire interval, it seems that the slope is negative, so the function's decreasing. But it started out a shallow decrease, getting more and more steep. So on this interval, the function f of x is decreasing because the slopes are negative, and concave down because it is decreasing and getting steeper and steeper. Finally, from x equals 12 all the way up to x equals 18, we again see that the slopes are positive. Positive slope. That means we have an increasing function. But notice how the slopes change. the slope is first 1.5, and then it changes to 2.5, and then it changes to 5. So the function's increasing with a slope of 1.5. So that's like a shallow increase. Then it changes to increasing slope 2.5, so it's steeper. And then it's increasing slope 5, so it's even steeper. Positive slope, function increasing. Slopes are increasing, so the function is concave up. So overall on this interval, it is increasing and concave up. Altogether, when we put all these pieces together, the function was increasing concave down, then decreasing concave down. So it is increasing concave down, then decreasing concave down, then increasing concave up. So roughly, we see a function that resembles this.